as Kara said, I have been a system engineer at Salesforce. I've been there now 3.5 years. We started our Puppet adoption 2.5 years ago. And really, I'd say launched off with PuppetConf in 2012. And what I'm going to talk about is the general notion of how do you adopt Puppet when you already have a large infrastructure. This slide is standard safe harbor, boilerplate. Basically, if I talk about something that's bad, assume it's one of my prior companies. Before I worked for Salesforce, I worked primarily in the financial sector. I worked for most of the larger companies in San Francisco. Definitely large infrastructure. If I'm talking about mature or legacy, that pretty much epitomizes it. So, Salesforce, if you're not familiar with what we do, it's a 16-year-old cloud computing company. We were one of the first to sell software as a service, as a subscription, where we host it on our web servers. You just log in through a browser. We have data centers around the world.
I'm super sorry. The mic is just not close enough. Do you want a handheld one?
Yes.
I promise this is a totally different mic. I promise. I'm so sorry. I'm so scared. You have to turn that one off. We'll just pull it out. Thanks. Sorry, Jason.
All right, is that better?
Yes.
All right, thank you. So we have data centers around the world. That has become an accelerating trend ever since 2011 when certain information came out about our government. Now there's a large demand for data centers in actual premises, so we are accelerating it very quickly. As a cloud company, we're very horizontally or vertically scaled type of organization. We form multi-tenancy stacks of servers, 10 plus server types, maybe 100 plus nodes each. But largely it's a building block, and so you have a certain scalability advantage there. But you have mass. We passed 10,000 servers a while ago. We're passing 20,000 soon, and really all of the automation work we're doing is geared at the notion of how do we get to 100,000 and still sustain it. With that, obviously, automation is a necessity. We came to this realization 4 years ago that we were running out of time to figure this out and do better. I think we bought ourselves a little bit of time when, with the last set of Xeon processors, when they doubled their core counts effectively from 4 and 6 and 8 to now 10 and 12 and 16. Realistically, we're not going to expect much more than that. I don't think we're hitting limits of what they can do for a 1U, 2-socket type server. So, we're going to be talking about this in really 4 sections. One will be an intro to the general problem. The next will be the methods that we used. And the third part, we'll talk about our implementation. And then fourth, lessons learned, gains, win, and where we're going after that. So, start with a basic question. Why do we want Puppet? There are a lot of general reasons, but at the heart of it, for as I'm talking, it's really about scalability. That if you don't have an effective system configuration management system, the costs start increasing sharply as your node count increases. I say as a general ballpark, when you're talking about a cloud style company, as you hit the thousands of servers, that's where things that's where the inflection point is. But one of my financial companies, we had fewer servers, but far more apps. We might have had 600 servers and 400 critical apps. So a company like that, you may already be hitting the criticality point at 250 servers. And then the other measure where you start to see a scaling start to fall off is when your system engineer count passes 20. The more people you have, the harder it is to maintain consistency. If you adopt a follow the sun model, you're in different data centers, you're in different regions, you're in different time zones, you may only talk periodically. At Salesforce, we have a meeting every couple of weeks at 8 a.m. because that's the only time that Dublin and Singapore and Virginia and San Francisco can all talk sort of at the same time. But geographic separation basically starts translating to different behavior. Former company, the people in Japan were really on their own island. They did things their way. And so that sort of scale, it just gets awkward. And what starts to happen is you lose reliability, you lose velocity, and you can't just hire more people to solve it. I mean, well, for starters, you can't hire more people anyway. Right now we're in a seller's market, but even assuming you could hire all the best engineers you wanted, it's not actually about them, it's just about the coordination of that many people. So this leads to a question now, will Puppet adoption make our jobs unnecessary? And the answer so far for us is not at all. I'm working longer hours than before. We're quite busy, but what we're not busy doing so much now is building servers. We're not so busy building data centers. We're doing work that's actually valuable. We're increasing our ability to handle moratoriums selectively or to get products out the door faster. We're letting machines do the road work, and that's really what Puppet is going to do for you. So, I'm talking now about the greenfield versus the brownfield. This is a topic that we've talked about my company quite successfully for years. You may be familiar with it. But in short, greenfield is your new environment. You have a clean slate, maybe you're a new company, you have a new product line, you have a new data center, but you basically have the ability to do whatever you want. You can work your business hours, you don't have a strict deadline, and you don't have business to interrupt. So really you're in a development environment. And in that, your primary cost now becomes time. If you're a startup, you have the perfect greenfield, but you may have other competitors trying to come to the same business, and you also have a finite amount of VC capital. At some point, you have to start making money. So opportunity cost doesn't go away, but many of the other barriers to implementation are removed. And that does allow you to go much, much faster. In contrast, the brownfield. The field's been paved over, you have servers running, you have customers. Now you may be restricted to doing work in off-peak hours. You may have very restricted windows or lengths of time you can work in. You really need to be testing ahead of time. You need a backup plan, a viable DR. And if you fail, you may lose direct revenue, you may lose customers forever. It presents considerably different problems. And I point to the Bay Bridge. Forgive me for using the western span, I could not find a portrait picture of the eastern, but everyone's lived here has seen the 30-year saga to get that thing repaired, 26-year saga to get it repaired after the earthquake in '89. And the problem is simple. 300,000 people drive across it every day. And it's this large, massive object. You just can't plop in a replacement and go. You have to do it in place without disrupting service too badly. So they close it down on weekends, they close lanes at times, they reroute it at times, but ultimately here we are. It was a big endeavor, and thankfully now we're basically done now. As you can see, doing it did leave some compromises, and we may have a slightly flawed bridge as a result. So I guess these screens are big enough. How many? These are 4 web servers. Do they all look unique? Actually, I really blew that punchline. So they look identical. And the answer is, of course not. They're snowflakes. Snowflakes are small variations of the same server type, and they emerge over time. They come when you have humans building them manually every time. They can still result if you're using Kickstart scripts, because your Kickstart script of June is not the same one you might have had in February. Did they get updated? Did all the servers from before get updated? Probably not. When you have a fire drill and you have an incident, your immediate response may be to fix the ones that were affected, but did you roll it out to all of your others? And over time, you end up developing a tribal knowledge of these servers are this way, and these ones are that way, and this is why. That again, when you have more people, that doesn't relay well. And what you end up having are many, many nearly identical, but not quite. And maybe the variations are bigger. Maybe one's running Red Hat 5.3, one's running 6.2. Maybe it's more subtle, you just have different kernel tunings. But in an incident, those differences can slow down your ability to troubleshoot and remediate. So now we're looking at a picture of the ultimate brownfield. We're not just paved over, we're fully built up. I think the best example of this, if you go on the Union Square, is the construction of the T-line extension to Chinatown. That is a highly disastrous, very difficult project because it's already been built up. Now they're basically digging into the ground to find new space, and in the middle of one of our biggest commerce centers. So this is really your mature company, your big company. It doesn't get greener with time. Tech debt only tends to accumulate. If you're doing really well, you manage it, much the way that a nation manages its debt. You just try and keep the growth small. The only time it really goes away is if you shut down a product, if you decommission a line of servers, if you shut down a data center. That's where you get a big jump. But otherwise, it's just all your needs from day to day tend to override paying down tech debt. The larger companies also tend to have a higher compliance and regulatory requirement, the financial world where I was in especially. As you have larger customers, the Fortune 500 companies tend to have stricter audit requirements, PCI and so forth. Change management comes along as a natural response to your scale. You need to, and I actually fully approve of change management, you need to have recordable changes that someone in a different time zone can actually understand, troubleshoot, replicate. If you don't, then you have a situation where an engineer leaves for the day and nothing can effectively happen until the next day. But change management is another barrier to implementing things quickly. And I find it's often not very friendly to the kind of changes that you implement with Puppet. It's much better at describing hands-on, run list type changes than a configuration change that's applied to the entire universe. Larger companies, and smaller companies for that matter, tend not to have very good staging environments. What you have in production is a different beast than what you may have in staging, particularly in terms of the load put on it and the inventiveness of the users. And then most importantly, if you're driving 5 billion revenue per year, you don't want to lose that. You want to maintain that and grow. So making a substantial change like this feels very, very risky. This is a big investment, and if done wrong, you can have very drastic effects. The counterpart to that is if you don't do this, the tech debt continues to accumulate, and eventually you stagnate anyway. Consider it no different than investing in money market accounts right now. In the short term, you make your 0.2%. But when you factor in inflation of 2% every year, you are slowly falling behind. So we looked at this project initially. We thought this was a very technical project. And 2 years later, it's very clear that was just a small aspect of it. And it's really about getting the pieces in without disrupting the existing. So keep that in mind and be prepared for things to go not as planned. So let's talk about methods. Right off the bat, we formed a DevOps team, and that is a very loaded word these days. It's almost been abused. So I'm going to make a nice simplification of it. From a system engineer's perspective, DevOps is treating your infrastructure as code and managing it like software projects would be managed. The QE people have worked on this. They really had a revolution 15 years ago. They did a lot of work on this, and it works very well for us. Code revision, collaboration with tools like Git, automated testing, and Jenkins and such, and the idea of code coverage. I've been a system engineer for a good 2 decades, and I had very loose ideas on this, and I had notions of code coverage and how to test effectively by hand, but they were not very formalized, and that was that was par for the course with the company I was at. We were basically wizards, and the quality of our testing and our code coverage varied dramatically. Joining this team and having very strict automated testing in particular was something I've never had. I had a lot of manual testing that I thought had good code coverage, but it takes time every time. Now it's free and done in the background. Salesforce is an agile shop. We use Scrum, which is, we use our version of Scrum. I think that lends itself well to this sort of project scale. If you try to boil the ocean, you end up spinning your wheels and not delivering anything. We worked on a 2-week Scrum schedule. If you focus on small deliverables at a time, I think that you get a faster result overall. And then as far as who you want on your team, we were very fortunate. We had a person that had done a similar project at a prior company. He'd actually brought into our team 2 ICs who had worked with us at the same time. And so with that, we have a DevOps person with extensive Puppet experience. There aren't a lot of those out there yet, though. That number is growing. So if you can't get that, the next best thing was really someone like me who had moved data centers before. They're not terribly different projects. You're changing servers in flight. One, you're rebuilding them, one, you're relocating them. But the whole notion of breaking into manageable pieces and keeping servers up really play together. So that's a good secondary approach. And then the third critical element is that you do want people with production experience in your company. You want people to know how the thing is supposed to behave, and really the whole point of optimization is to simplify their work or to reduce their row work and let them do other work. So not having them represented is not good for you. You do get this tension, this very good beneficial tension between the engineers and the operations folks here. The ops people have a feel of how it should be and what they need, but sometimes they're wrong. Sometimes what they want is actually not the best way to scale. And so the collaboration of the two plays out very well for you. So we did a few things to build up our initial skills. One of the strengths that Puppet Labs presents is that they give you a lot of options and a lot of avenues. Brian just spoke about several of them. Many, and they continue to evolve. Puppet Camp is a good example. This is a very cheap option. You see the talks ahead of time. If they are valid to you, you come and you get the benefits. My team initially, 2 of us were new to Puppet. We took the fundamentals class. The other 4 members, were more experienced. They took a more advanced class that was actually held on site and was effectively custom tuned for us. And then PuppetConf 2012 was our first large conference. PuppetConf is good for getting case studies, for seeing what other people are doing, and for upcoming tools. We also engage professional services, and this is something that if you're starting a project, may be very advantageous. The product is evolving very quickly, and you look at the written material and case materials, it may be based on the past, and you look at the methods that we used. If I were starting it now, we would probably not use the same ones. We did a lot of things hand-built and custom crafted, and to fill the needs that were not there at the time. At this point, the matrix of products is different. Ben Ford was our engineer. He was on site with us part-time for the better part of a month. And aside from helping us with some architectural decisions, did initial reviews of everyone's code to try and instill consistency and best practices. He also helped us with a very key product, our virtualization product for testing. Puppet Forge, like any other shared common utility code repository, if the problem's already been solved, you need to solve it again. Take advantage of what's already been done. Evaluate it, but take advantage. Our general approach has been that code from the Forge, we will generally trust but still scrutinize, but if we're pulling code from the wider internet, we apply greater scrutiny. Similar as you might with almost any vendor tool. And then last, Puppet user groups, meetups are held every month or 2. There have been some good talks this year. Those again, if you see a talk that is applicable to what you're doing, it's free. And it's even in the evening, so it's a pretty easy time, usually beer. So now let's talk about our game plan. Off the front, we had 3 key epics. First was creating the base class. We really want our service to be as similar as possible to each other, except for they have to be different. And so our first work was to take 100 plus kickstart scripts with 10,000 lines of bash code, figure out what actually still mattered, what was irrelevant, and drop it down into simple modules. Our kickstart scripts had a lot of sed type substitutions where we take the file, append it, substitute, append, substitute. Things that Puppet templates do very well and with much greater clarity. That's one of the strengths of the DSL is that it's very readable code. Even for your operators who don't necessarily know Puppet, it's very easy to read most Puppet manifests, especially the simple ones, configuration files, permission settings, RPMs, designations. 70-80% of your code is very straightforward. Next thing we did was build our Vagrant environment, which we call Puppet in a Box. 3 years later, there are a lot of options here, and it's a much stronger space than it was. But basically, having our Vagrant environment meant that we could give every developer the ability to build every single type of node on their workstation. We didn't need to get a VM from IT. We didn't have to get staging environments. And this, of course, would then be the backbone for our testing environment as well. As a further plus, it's not restricted just to Puppet development. I used it to test patching scripts that we were using for the legacy service. It's just the ability to build an instance, make changes to it, destroy it quickly. Much better than things used to be. And then the last focus we did really on our first 4-month release cycle was, what are the practices we want to do? How do we want code developed? What kind of Puppet code standards do we have? Things like extracting variables into Hiera and our CMDB wherever possible. All code gets reviewed by another person. All codes have RSpec and Puppet-lint and functional tests available. We didn't want to have different manifests for different roles looking radically different. We wanted to maintain consistency to that. And some of that time up front was very valuable in that sense. This is some of the open source tools we used. I mentioned we rely on Git, we're tremendous fans. Vagrant, Jenkins, Puppet-lint. Rouster is a functional testing platform that was created by one of our engineers during this process. He actually presented this at PuppetConf a year and a half ago. If you don't have enough test protocol, it's worth looking at. It's actually very good even before you Puppetize, in that you can build your functional tests and use this product against your legacy role types. And then as you make your conversion, confirm that the tests still pass. And here is a subject that's very touchy, very difficult in an older environment. Production access is a non-issue to startup. In a financial, it's almost a given that only the system engineers will have access to root, and sometimes only to production at all. This can be driven by regulatory considerations. Sometimes it's a decision that the company made, that we only trust the Unix people. We don't trust the developers. And it's very difficult for engineers to automate something they can't look at. You're really you're tying their hands behind their back if you do that. So if you are in a situation of this type, you have developers in your team that don't have access, at least ask the question. See if you can get better access. Because without it, your bandwidth gets limited to your system engineers. At one point a year and a half ago, I was it, and we'd spend our days in our testing rounds with 5 people watching my screen, either in person or remotely. It's not good for them, and it's really irritating if you look at the keyboard. We've made headway since then. Our first step was that all of our developers were given production access on a login basis. No special privileges, but at least they could get on, they could see, they can look at a lot of things without privileges at all. But then the next step was to get a whitelist of read-only type pseudo rules, in particular Puppet no-op, being able to look at the certs, puppetmaster.log. So with that, if a problem comes up and I'm not around or one of the other system engineers is not around, developer can look and they may have the answer in minutes in the a solution already committed into code, and then it's just waiting deployment. You will get much better speed and much better results if you can get them at least that level of access, and do what you can. So, at the beginning of your implementation, you have your base code, you have rules defined. How do you actually start turning the wheel? Your infrastructure might be an oil tanker. You're turning the rudder. There are at least 5 ways I think you can engage this problem. The first is you're building a new data center. So don't worry about the old, let's just get the new one right. And this was initially what our strategy was. We were building a new data center pair, and this was going to be our automation DC. And when that one was successful, then we were going to build out more, and we were going to migrate the old. The catch you run into this, and what happened to us, is that we overscoped it. We not only wanted to puppetize, we wanted to automate our storage, our network, bring in a new CMDB. And so there were 6 different Scrum teams all operating. They didn't deliver on the same schedule. The other problem is that changing every role simultaneously means it's all or none. DB in particular is a very hard role to convert. And as a result, we had code, we were ready to start integration testing. How successful it would have been, I'm not sure, but because other components weren't ready, we didn't even get out the door. And we spent part of that year retesting other purposes, patching automation to other security concerns. And so we basically treaded water for a bit. So I think that one's, it looks like a greenfield, but it really isn't. And even if you do it, now you have 2 tracks. You have how your new servers look and how your old servers work. So in the short run, you're increasing the difficulty for your operators, not increasing it. Next style you can do is only new hardware will have the automation build. We do a refresh cycle on a 3-year basis. So you start rolling out all the new servers, then in 3 years, the problem's gone. But again, you have to solve all the role types or all the roles you support, and you have this dual track thing going. It's a mixed bag. If you're doing selective refreshes, then you may have synced the same role or the same product, or in our case, same instance with mixed types. Very difficult for troubleshooting problems. Third one actually may be a favorite one. You're releasing a new product. Puppetize that one. Get that out the door, learn some lessons, and then move on. This may not be a bad strategy. The only gotcha is that if the work it takes you to finish the Puppet infrastructure is longer than it takes to roll the product, you've now delayed it. And so you've tied them together. That may be disadvantageous to the product. But I think it's an avenue worth looking at. It may be a very good one. The fourth, I think, is my least favorite, converting a single resource at a time. Now you run into a situation where you're rolling out 100 changes to every one of your servers. And each time you have the potential to break it. And from an operator perspective, what's being maintained by Puppet and what's not. Wherever we can, with files that allow for comments, we put on a header, this is managed by Puppet, and we put the path to the module that does it. That's a good practice anyway, because if the module's not behaving the way that the operator believes, they can at least go straight to the source. But I feel that being a little Puppetese, being a little pregnant, it's just puts you in a tough situation. Then the last one is the one we end up succeeding with. We took a single role, we converted it entirely within the company, and we went to the next role and so forth, and we iterated that style. Part of our impatience was we wanted to get something out the door. We wanted to show that it would work at all. And we wanted to learn something. You have these notions up front of how it will behave and how it will function. But until you actually go live, you don't know. And that's when you start to learn. So we started with an internal role, and then we started with a non-customer facing role, and we started with simple roles. In our case, a lot of our servers are just simple Java servers. They're not particularly complicated from a Puppet perspective. They're very critical from a production perspective, but they're easy. And in our case, the first 30% of our roles are in that category. So, early last year, we were starting to plan for our next PCI audit. Our objectives are to stay within 2 minor releases of current, and we made the decision that we wanted everything on Red Hat 6. We were running some things still on 5 and some things on 6 on current tracks, but we wanted to converge that. And for 35% of our servers, that meant upgrading from 5 to 6, which to me has always been a reimage. It's not a yum update. I prefer reinstallation when time on a major change. But in our case, that's thousands of servers. And what we proposed was that we're going to spend the time anyway. This is our time to do Puppet. This is time to get the conversion. And from then on, things will be better for us. The timing was good in that we'd just gone to one of our remote offices. We'd spent a week training 4 people. And in the time, they built about 400 nodes into Puppet. And that showed that we could do pretty good velocity. And the other key change, because of the delay we had in getting out the door, our orchestration product had caught up with us. And now we have the ability to convert nodes faster than it would be to kickstart and install the apps. Now we have a push-button GUI that will shut down the server, take out the load balancer, take out the monitors, re-image it, let the Puppet run, lay down the roll, reinstall the apps, turn it back on, and turn on the monitors, put it back in the load balancer pool. 45 seconds of work for the operator, 65 minutes of real time. But 1 person rather than a handoff between our release engineers and the operators. And within 2 days, they figured out how to do that in curl so that it took them 2 seconds per node. They basically scraped the web submission page. And with that, we converted the first 4,000 nodes in about 3 months. So, how do we convert a role? So, your pre-production work is what you'd expect. We test it in our virtual environment, build the manifest, review with the role owner, do your Jenkins testing. Our initial smoke test is that we use a disaster recovery instance, non-customer facing, non-active, just make sure functionally it would build. And we would go to one node in our production internal infrastructure. As I said, Salesforce uses stacks of servers called instances. We have one that we use ourselves internally. So that always became our first production instance that we would touch. If that's successful for a couple days, then we would proceed to convert a couple nodes on our first externally facing, customer facing instance. And that would be a longer bake. That might be a week, it might be longer. Find bugs, iterate, repeat. And then once you felt comfortable that those smoke tests had passed, then it's just convert the rest. Use all hands you have available, do it as fast as possible, retire the Kickstart scripts forever. And then at the end, do your retrospective. What went wrong? What did you learn? How do we do the next role differently? And it led to an adoption chart like this. Note that it's very nonlinear. This is a very important message, I would say, to the project managers and the upper managers, that the first 3 to 5 roles, 3 to 5 nodes in any given role, might take 3 or 4 weeks. And then the remaining 95% of your servers, whatever you have left, can be done in a week or 2. It can be extremely rapid. So you end up getting a very spiky delivery pattern. Now, we made a couple key strategic decisions very early on, one of which, the very important one, the most important one I think, is that Puppet runs continuously. I've seen companies where they do not do this, and if that's the case, very quickly, you've reinvented Kickstart. So if you ever want to make updates, now you're re-imaging the box again. And even with non-Puppet products in the past, I've seen the same mistake. I was at a place that invented a very fancy version of rsync that was effectively a lightweight Puppet. And while we did not run it continuously, And the end result was that if you wanted to push all changes and update currently, you might see 100 changes. And that's a lot to be doing at once. The high risk that you will cause a regression. And then the other obvious reasons are our whole intent is to reduce snowflakes. So having continuous runs means that if someone goes in and manually edits, it will be undone. Very important. We introduce a canary release process. In our sense, canary is really more like a deployment test. We deploy to that internal instance first. We let it sit there for 18 hours, and it automatically promotes everything else. Very conservative, but we were dealing with a great concern of would we break production. And the general notion, we've been described as weapons of mass destruction because we now control more than half of production. Bad change, obviously, very bad. Canary is there really to ensure that if bad code makes it through the automation process, her internal instance will immediately be seen by the people in the company. We stop the promotion, fix it, and repeat. Thankfully, in 13 months of production, we have yet to actually have to do that. And then the third decision we made, we kept everything very internal to the team. This doesn't scale in the long run, but in the short run, it maintains consistency, and I think it gives you better reliability. The people involved know everything. They know the mistakes, they know the reasons. So getting out the door and establishing a reputation, I think, is a key choice. So I'm going to have to accelerate a little bit here, but let's talk about what we learned out of this. We learned a couple lessons right in the beginning that because we'd written our code a while ago and it took a bit to actually get into production, the target had moved. We had started moving from Red Hat 5 to Red Hat 6, but our code for one of the first roles we converted was written during Red Hat 5. What happened, Red Hat changed the default patterns for transparent huge pages. We converted the first half of our instance, and they started seeing performance regressions. Fortunately, they were fairly sharp ones. They were very obvious, and that code was fixed. What this really proved is that if you have bad code, it's going to be bad everywhere, consistently bad. And while that can be very destructive, it's very easy to troubleshoot. And I think the benefit of removing snowflakes. Second one, we kind of did later in the summer. We put in a very simple configuration hardening change. It broke one of our old tools. And we found it, we changed the template back. As quickly as we deployed it, we could very quickly undo it. Which again, if you go with the idea of MTTR, anytime recovery, fail fast, recover fast. You can't stop failures. You do your best, but the key is to be able to undo it if you have to. The irony of that one is that if they had deployed that to the legacy servers, they would have wanted to use the same automation tool that was broken to do it. And so since we deployed first and identified it, they never did and avoided that fun experience. As we were talking to management about our progress and reporting 1,000 this, 1,000 that, we were getting general, okay, that's great. But it wasn't until we showed the time savings that we got true manager support and driving others to adopt. And it came down to a simple resolver change. That took 20 minutes of work for me to do and have someone else review. Our automated testing and deployment was already a sunk cost. And we fixed 2,000 nodes in 20 minutes. And if we had 10,000 nodes or 100,000 nodes, it would have been the same 20 minutes. And doing that on the old machines where they're Snowflake, they're not always the same, they're not even the same OS. You now have to write scripts that take care of all the edge conditions. And when you run it, you may miss 2% of the nodes. With Puppet, we know that's declarative language, it will do it. We know we'll do it with all of them. It will report the ones that don't. So you can push out changes faster and more reliably. And that is really the key. There are a lot of items that we'd like to do or tech that we know we have, but the time it takes to actually deploy it exceeds the value, so we don't. We just let it sit. When you take that problem away, you can do a lot of work that has been outstanding, and you can do it very cheaply. Simple password rotations, file perm changes, easy once. And so now you think about the 4 snowflakes we had at the beginning that were non-identical, slowly moving, Now you replace it with 4 supersonic jets that are in exact unison, and you make a change to all 4 of them that stay in that unison. That's the velocity increase, and that's the consistency benefit that you get. Now what wasn't working for us was, again, we consolidate everything into a single team. We control all Git manifests, we control all code pushes. That doesn't scale as soon as you start getting all those other teams ready to adopt. We were the gatekeepers and the bottleneck. If they submitted bad code, if they didn't have Puppet Lint working, they'd put in a pull request, we'd look at a day or 2 later, we'd say that's not bad, we'd bounce back to them. The iteration cycle was as much as a week. And it's frustrating for them, and it was a time drag for us, so it was good for no one. So we changed our model, and this is where R10K came in. As an interesting point, we learned about R10K at a Puppet meetup last year. I think in July last year. A week later, we had a POC, and 2 weeks later, we had it deployed. Highly successful for us. In our case, what we do is to transfer ownership of Git repos to other groups. What we had found is that every repo, every Git manifest that we defined, we became the owners of. We owned every role we converted. We owned base class. And we weren't really staffed for that. And clearly that doesn't scale when you're talking about 10,000 servers. So R10K allows us to give the Git repo ownership for their manifests to each of the groups. And then they submit pull requests to us to update the global makefile. So they can do all their testing of themselves. They can do their functional testing. And when it's time to come to us, we just make sure that it passes our pre-deployment testing. And if so, it gets merged in. If it affects base class, it gets tested, and that's left open for us to do a quick review. And if everything seems fine, we do that. Our deployment process is a fairly simple one of change management, get approval, push it out to the canary house, and it sits there, and then we have a cron job that twice a day at noon and 4 o'clock checks to see is there a Puppet release that's more than 18 hours old enough to promote. We only promote Mondays and Thursdays, those 2 times. Because again, our team is still concentrated here in San Francisco. As we evolve, that will change, but in the short term, that is the most sensible. We don't want to do Friday releases yet. We definitely want to do weekend promotions. But as we get more comfortable and as the company increasingly in other regions is more comfortable, then we can expand that. Our immediate goals on future improvements now, we want to move from, we're releasing about twice a week. And we want to build that to the point where we're doing it 3 times a day. The company will be comfortable as we slowly increase that cycle. Whether or not we'll ever go to the cycle, some companies will release every single code commit. That may not be necessary. Ours are generally less than 10 commits. And that's a reasonable number, but the smaller the commit count, the safer it is, the quicker it is to retract if you have a problem. You just don't want to do large ones. And in our early days when we were busy, we might do it every couple of weeks, and you might have 100 commits. That's definitely not the course you want to take. We'd given the ability for other teams to contribute code, but we found that that was not enough. And so we spawned off the second part of us that will work very closely with them purely on adoptions. I think in hindsight, we forgot that we'd spent 2 years working on this, and they had just spent a couple months. And they, again, are still uncomfortable with the fact that they are disrupting what they already know works to something that is new. So having this team foster that should help us. I'm particularly interested in working on patching improvements, expanding our feature flagging. So instead of just having canaries that run for 18 hours, that we have canaries, what I call baking class, that might run for a week for higher impact changes. And last, we want to give the ability to selectively freeze certain instances in production. That gets against our notion of snowflakes elimination and everything being the same. But we're in a model now where there's really 2 out there. There's the current and maybe the past version, but there aren't an infinite number of variations. And with that, I thank you. And if there are any questions, I have almost no minutes.
Take them during the break. People can come up and chat with you.
All right, then let's do that.
Perfect.
Thank you.